वालेकुम डियर स्टूडेंट्स। इन क्वेश्चंस के अलावा जो कि मैं वीडियोस बना के लगा रहा हूँ, अगर आपको कोई और भी किसी और एक्सरसाइज से कोई और चैप्टर से कोई क्वेश्चन आपने समझना है, पूछना है, तो आप मुझसे रब्ता कर सकते हैं और मैं कोशिश करूँगा कि प्रायोरिटी पे आपके जो बताए हुए क्वेश्चंस हैं वो उसकी वीडियो बना के मैं अपलोड कर दूँ। थैंक यू। टुडे वी डिस्कस क्लास 9 exercise 1.5 in which find the determinant of the following matrices. The question 1, first part is A matrix minus 1, 1, 2 and 0, and we find the determinant of 1, which is A determinant is equal to the matrix 1, 1, 2 and 0 is equal to. For finding the determinant, we multiply this to this value minus this multiplied by this. So minus 1 multiplied by 0 is equal to 0, minus 2 multiplied by 1 is equal to 2, which is equal to minus 2 is the answer. Determinant of E. And part second is matrix B, which is 1, 3, 2, minus 2. And determinant of B is 1, 3, 2, minus 2. To find the determinant, we multiply 1 with minus 2 is equal to minus 2, minus 2 multiplied by 3 is equal to 6, which is equal to minus 8. And the third part is C matrix. The C matrix is 3, 2, 3 and 2. And C determinant is equal to 3, 2, 3, 2 determinant. And solve the C determinant. 3 multiplied by 2 is 6, minus 3 multiplied by 2 is 6, which is equal to 0. And fourth part is matrix D, which is 3, 2, 1 and 4. And D determinant is 3, 2, 1 and 4. Now find the determinant of D is equal to 3 4s are 12, minus 1 multiplied by 2 is equal to 2. 10 minus 2 is equal to 10, which is the answer of part 4 determinant. In which find the following matrices are singular or non-singular. Students, when determinant of a matrix is equal to 0, it is called singular matrix, and if it is not equal to 0, then it is a non-singular matrix. So let's start. Question 2, part 1. The matrix we say A. 3, 6, 2, 4. A determinant is equal to 3, 6, 2, 4. Now we solve the determinant A, which is 2 4s are 12, minus 2 6s are 12, and 12 minus 12 is equal to 0. This determinant is equal to 0, so it is a singular matrix. Singular matrix. And part B is, part 2 is B matrix, which is 4, 1, 3 and 2. Now we take the determinant of B, which is 4, 3, 1, 2. Now solve the determinant B. 4 2s are 8, minus 3 ones are 3. 8 minus 3 is equal to 5, which is not equal to 0. So B matrix is non-singular. And the third is C matrix, which is 7 minus 9, 3, 5. And C determinant is equal to 7 minus 9, 3 and 5. Now we multiply. 7 multiplied by 5 is equal to 35, minus 3 multiplied by minus 9 is equal to minus 27. Now we solve it. 35, this minus multiplied by minus is equal to plus, 27 is equal to 62, which is not equal to 0. So C is non-singular. D matrix. The D matrix is 5 minus 10 minus 2 and 4. Now we find the determinant of D, which is D determinant is equal to 5 minus 2 minus 10 and 4. Now we simplify these values. 5 4s are 20, minus 2 then multiply by minus 10 is equal to plus 20, and 20 minus 20 is equal to 0. So D is singular. Question 3, in which find the multiplicative inverse if it exists of each. So we find the multiplicative inverse if the matrix exists. Now we start. First part is equal to A matrix, which is equal to minus 1, 3, 2 and 0. And before multiplicative inverse, we find the determinant. If the answer is singular, the multiplicative inverse not exist. And if it is non-singular, then we find the multiplicative inverse. Let's start. A determinant is equal to minus 1, 3, 2 and 0. Solve it. Minus 1 multiplied by 0 is equal to 0. Minus 2 3s are 6, which is equal to minus 6, and it is not equal to 0. So the matrix is singular. So we can find the multiplicative inverse of A. And after finding A determinant, we find adjoint A. And the adjoint A is equal to adjoint A. A matrix is minus 1, 3, 2, 0. And when we apply adjoint A, adjoint on the matrices, we shift the interchange mean. These two values mean 0 and minus 1. And these values change the sign, minus 2 and minus 2. This is the adjoint of A, and A inverse is equal to adjoint A over A determinant. A adjoint is equal to this value, the matrix 0, minus 3, minus 2, minus 1 over A determinant is equal to minus 6. And it also we can write it 1 over minus 6 into 0, minus 3, minus 2, minus 1. And at this stage, we multiply the scalar multiplication of matrix, mean minus 1 over 6 multiply all the elements of the adjoint of A, which is 0 multiplied by 1 over minus 6 minus 3 multiplied by 1 over minus 6, minus 2 multiplied by 1 over minus 6, minus 1 multiplied by 1 over minus 6. And now we simplify the values. 0 multiplied by minus 1 over 6 is 0. Minus cancel with minus. 3 ones are 3, 3 twos are 6, and it is 1 over 2. Minus cancel with minus, 2 ones are 2, 2 threes are 6, which is 1 over 3. Minus multiplied by minus, which is 1 over 6. And this is the inverse of matrix A. Similarly, we solve the part second, which is matrix B is equal to 1, 2, minus 3, minus 5. Before finding the multiplicative inverse, first we find the determinant of matrix. So we find B determinant is equal to 1, 2, minus 3, minus 5 determinant. Now solve it. 1 multiplied by minus 5 is equal to minus 5, minus 3 multiplied by 2 is equal to minus 6. Simplify it. Minus 5 plus 6 is equal to 1, which is not equal to 0. So it is non-singular. Non-singular. Sorry. In part 1, it is minus 6, which is not 0, and it is non-singular. Because if the determinant is equal to 0, then the answer is singular, and we cannot find the multiplicative inverse. And if the determinant of the matrix is non-singular, then we find the inverse multiplicative inverse. So B is non-singular, so we find then adjoint B, which is equal to adjoint B. The B matrix is 1, 2, minus 3 and minus 5. By applying adjoint to the matrix, we get minus 5, 1, 3 and minus 2. And this is the adjoint of B. Now then we will find B inverse, which is equal to adjoint B over B determinant. Adjoint B is equal to minus 5, minus 2, 3 and 1. We write it. And divided by B determinant, which is equal to 1. And now we divide all the values with the determinant. We find minus 5 over 1, minus 2 over 1, 3 over 1, 1 over 1. Simplify these values. We get minus 5, minus 2, 3 and 1. And it is the inverse of B matrix. And it is the second part of question 3. Sorry, third part of question 3, which is C matrix. C matrix is equal to minus 2, 6, 3, minus 9. Before finding the multiplicative inverse, we find the determinant of C. Now we solve it. Determinant of C is equal to minus 2, 6, 3, minus 9 determinant. Now we solve the determinant of C, which is minus 2 multiplied by minus 9 is equal to 18, minus 3 6 are 18. It is equal to 0, and it is singular. So C matrix is not exist for the multiplicative inverse. And the fourth part is D. The D matrix is 1 over 2, 3 over 4, 1 and 2. And we find the determinant of D, which is D is equal to 1 over 2, 3 over 4, 1 and 2. find the determinant of D. 1 over 2 multiplied by 2 is equal to 1 minus 1 multiplied by 3 over 4 is equal to minus 3 over 4. When we simplify it, we get 1 over 4, which is not equal to 0 and not singular, mean non-singular. And we know that when the matrix is non-singular, we can find the multiplicative inverse. And it is not equal to 0, non-singular, we find the inverse of matrix D, and after finding adjoint determinant, we find the adjoint. Adjoint D is equal to adjoint D matrix is 1 over 2, 3 over 4, 1 and 2. And when we find the adjoint of the matrix, we change their positions, we get 2 and 1 over 2 and change their signs, minus 3 over 4, minus 1. This is the adjoint of D, and we know that D inverse is equal to adjoint D over D determinant. Adjoint D is 2 minus 3 over 4 minus 1 and 1 over 2 and divided by 1 over 4. And now we further solve these values. The adjoint of D is equal to plus 2 minus 3 over 4 minus 1 1 over 2, and it is divided by 1 over 4, and when we multiply with the matrix, we get 4 over 1. Now we multiply 4 to all the elements of adjoint of D, which is 4 2s are 8, 4 multiplied by minus 3 over 4, which is equal to minus 3, 4 multiplied by minus 1 is equal to minus 4, 4 multiplied by 1 over 2 is equal to 2, and it is the inverse of D. Question 3, part 4. Question 4, in which we have two matrices A and B, and we solve these. The first is A matrix multiplied by adjoint of A is equal to adjoint of A into A is equal to determinant A into I, identity matrix. Now let's start. A matrix is 1, 2, 4 and 6. Now we find the determinant of A. A determinant is equal to 1, 2, 4, 6. Solve it. 1 multiplied by 6 is equal to 6 minus 4 multiplied by 2 is equal to 8. The answer is minus 2, which is not equal to 0. So it is non-singular. Now we find the adjoint. Adjoint A. Adjoint A is equal to adjoint. The A is 1, 2, 4, 6. When we apply rule adjoint A on the matrix, we get 6, 1, minus 4 and minus 2. This is the adjoint of A. And the first part is which we want to find A bracket adjoint A is equal to adjoint A into A is equal to determinant A into I, identity matrix. Now we solve these one by one. First we calculate A bracket adjoint A. A matrix is 1, 2, 4, 6 and determinant of A is 6, minus 2, minus 4 and 1. We multiply both these matrices, we get first the rule, the number of column is equal to the number of row. They are both equal, so we can multiply it. First row with first column, 1 multiplied by 6 is equal to 6. 2 multiplied by minus 4 is equal to minus 8. Then first row with the second column, 1 multiplied by minus 2 is equal to minus 2. Then 2 multiplied by 1 is equal to plus 2. Second row with the first column, 4 multiplied by 6 is equal to 24. Minus 6 multiplied by 4 is equal to minus 24. And second row with the last second column, 4 multiplied by 2 is equal to minus 8. Plus 4 multiplied by 1 is equal to, 6 multiplied by 1 is equal to 6. Simplify these values, we get 6 minus 8 is equal to minus 2. 2 minus 2 is equal to 0. 24 minus 24 is equal to 0. Minus 8 plus 6 is equal to minus 2. And in this matrix, we take common minus 2. The matrix is 1, 0, 0, 1. And the second part, adjoint A into A, we first multiply adjoint A into A, which is the adjoint A into A is equal to, adjoint A is equal to 6 minus 2 minus 4 and 1, 6 minus 2 minus 4 and 1, and A matrix is we have 1, 2, 4, 6. Before multiplying these two matrices, check the rule, number of column is equal to number of rows. They are both 2 is equal to 2, so they are conformable for multiplication. So let we multiply these two matrices. First row with the first column is equal to 6 multiplied by 1 is equal to 6, minus 2 multiplied by 4 is equal to 8. First row with the second column is 6 multiplied by 2 is equal to 12, minus 2 multiplied by 6 is equal to minus 12. Now second row with the first column, minus 4 multiplied by 1 is equal to minus 4, 1 multiplied by 4 is equal to plus 4. Second row with the second column is minus 4 multiplied by 2 is equal to minus 8, 1 multiplied by 6 is equal to plus 6. Now simplify these values, we get 6 minus 8 is equal to minus 2, 12 minus 12 is equal to 0, 4 minus 4 plus 4 is equal to 0, minus 8 plus 6 is equal to minus 2. Now take common minus 2, we get the identity matrix, which is 1, 0, 0 and 1. And this is the second value, we find adjoint A into A. And here we know that when we verify A adjoint A adjoint into A is equal to determinant A into identity matrix. Up. The third part is determinant A into identity matrix. Determinant A we know that minus 2, and identity matrix is 1, 0, 0, 1, and hence prove all these values. The first is A into adjoint A, which is minus 2, 1, 0, 0, 1, and determinant A into A, which is answer is minus 2, 1, 0, 0, 1, and determinant A into identity matrix is minus 2, 0, 1, 0, 0, 1. They are all the same values, so hence A adjoint A is equal to adjoint A into A is equal to determinant A into identity matrix, and it is our answer, and we prove the values in question 3. Sorry, in question 4, part 1. And now we solve question 4, part 2, in which B into B inverse is equal to identity matrix is equal to B inverse B, and it is also the identity matrix. And first we take B matrix, which is 3 minus 1, 2 minus 2. It is the matrix B matrix. So we find first B inverse, a multiplicative inverse of B, and then multiply these two values and B inverse into B, and prove that they both are equal to identity matrix. Now start. Before finding the multiplicative inverse, we know that we find the determinant of B, which is equal to 3 minus 1, 2 minus 2. 3 multiplied by minus 2 is equal to minus 6, minus 2 multiplied by minus 1 is equal to minus 2. Solve these values. Minus 6 plus 2 is equal to minus 4, which is not equal to 0. So it is non-singular. And we can find the multiplicative inverse of B. And the next step is we find adjoint B, which is adjoint B is 3 minus 1, 2 minus 2. And we find the adjoint of B, which is minus 2, 3, minus 2 and 1. This is the adjoint of B, and B inverse is equal to adjoint B over B determinant. Adjoint B is equal to minus 2, 1, minus 2, 3, and the B determinant is equal to minus 4. So we divide minus 4 with all element of adjoint B, we get minus 2 over minus 4, 1 over minus 4, minus 2 over minus 4, 3 over minus 4. Now simplify these values. We get minus minus 1 over 2, and it is 1 over minus 4, and the next is 1 over 2, and the last is 3 over minus 4. It is the B inverse. And now we find B into B inverse, which is B into B inverse. The matrix B is 3 minus 1, 2 minus 2, and inverse of B is equal to 1 over 2, 1 over minus 4, 1 over 2, 3 over minus 4. Now we multiply B with B inverse, and before multiplying we check the rule. The first matrix number of column, the second is number of row. They are same, mean 2 2, and they are conformable for multiplication. Now we multiply these two values. Row with the column is 3 multiplied by 1 over 2 is equal to 3 over 2, minus 1 multiplied by 1 over 2 is equal to minus 1 over 2. And the next first row with the second column is 3 multiplied by 1 over minus 4, we get 3 over minus 4, minus 1 multiplied by 3 over minus 4, we get plus 3 over 4. Second row with the first column, 2 multiplied by 1 over 2, 1 minus 2 multiplied by 1 over 2 is equal to minus 1. Second row with the second column is 2 multiplied with 1 over minus 4, we get 1 over minus 2, and minus 2 multiply 3 over minus 4, we get plus 3 over 3 over 2. Now simplify these values. We get 3 over 2 minus 1 over 2. We get 2 over 2, which is equal to 1. 3 over minus 4 plus 3 over plus 4. They cancel each other and get answer 0. 1 minus 1 is answer 0. 1 over minus 2 plus 3 over 2, we get 2 over 2, which is equal to 1. And it is identity matrix. 1 over 2 and 1 over 2 minus 3 over 4 and 1 over minus 4 and 3 over minus 4. 1 over minus 4 and 3 over minus 4. It is B inverse. And matrix B is, we know that 3, 2, minus 1, minus 2. We multiply these two matrices, and before multiplication, we check the rule. The column of first matrix, which is 2, with the column of second matrix, with the row of second matrix, which are also 2. So both the column and row are 2 is equal to 2. So they are conformable for multiplication. Now let's start to multiply these two matrices. First row with first column. 1 over 2 multiply with 3 over 2. We get 3 over 2. Minus 1 over minus 4 multiply by 2 is equal to 1 over 2. First row with second column is 1 over 2 multiply by minus 1 is equal to minus 1 over 2. 1 over minus 4 multiplied by minus 2 is equal to plus 1 over 2. Second row with the first column is 1 over 2 multiplied by 3 is equal to 3 over 2. 3 over minus 4 multiplied by 2 is equal to minus 3 over 2. Second row with the second column is 1 over 2 multiplied by minus 1 is equal to minus 1 over 2. 3 over minus 4 multiplied by minus 2 is equal to plus 1 over 2. Simplify these values. We get 3 over 2 minus 1 over 2. We get 2 over 2, which is 1. These are cancelled, 0. 3 over 2 minus 3 over 2, which is equal to 0. 1 over 2 minus 1 over 2 plus, it is 3 over 2. Minus 1 over 2 plus 3 over 2, which is, we get 2 over 2. Answer is 1. And it is identity matrix. So hence verified B inverse is equal to identity matrix is equal to B inverse B. Question 5, part 1. The two matrices are 3, 5, 4, 7, and the other matrix is 7, minus 5, minus 4 and 3. So we get the multiplicative of inverse of one matrix, first matrix, the answer is the second. And when we get the multiplicative inverse of the second matrix, we get the first matrix. Let's start. We take first matrix and we tell it A. A matrix is equal to 3, 5, 4, 7. And when we find the multiplicative inverse, we first find the determinant of A is equal to, determinant is 3, 5, 4, 7. And the inverse is, determinant is 3 7s are 21, minus 4 5s are 20. 21 minus 20 is equal to 1, which is not equal to 0. So it is non-singular. And we can find its inverse. And before finding inverse, we find the adjoint A, which is equal to adjoint. The A is 3, 5, 4, 7. The adjoint is 7, 3, minus 4, minus 5. And this is the adjoint of A. And A inverse is equal to adjoint A over A determinant. The adjoint A is equal to 7, minus 5, minus 4, 3 over A determinant is equal to 1. and we divide the adjoint of A with 1, we get the answer is 7 minus 5 minus 4 3, and it is verified. The matrix the multiplicative inverse of one first is, we get the answer second multiplicative value of second multiplicative 7 matrix second matrix, and now we find the multiplicative inverse of second, we get the first matrix. Now let's start. We get the second matrix is B, 7 minus 5 minus 4 3, and before finding the inverse we first find the determinant. The B determinant is equal to 7 minus 5 minus 4 3. Simplify these values. 7 3s are 21, minus 4 multiplied by minus 5 is equal to plus 20. 21 minus 20 is equal to 1, which is not equal to 0, so it is non-singular. And we find the adjoint of B. Adjoint B is equal to adjoint, the B is 7 minus 5 minus 4 3. Then adjoint of B is 3 7 4 and 5, and B inverse is equal to adjoint B over B determinant. Adjoint B is equal to 3 5 4 7, and B determinant is equal to 1. So we divide adjoint B with B determinant, we get 3 5 4 7, and here we also saw the second value of second matrix of second matrix inverse of second multiplicative inverse of second matrix is equal to the matrix of first, and before we solve the first matrix, get the multiplicative inverse, we get answer the second values. So it verified that the two matrices are each multiplicative inverse of each other, and similarly we